Greetings and welcome to Distillate. In the previous lecture, we talked about two-dimensional lists, wherein we needed more than one indices. Basically, we needed two indices in order to access an element in the list, right? And we also further talked about the possibility of multiple dimensional lists, and I've given such examples in the self-assessment test as well. Now, today onwards, so today and the subsequent lectures are going to be very, very important because now we are going to start an introduction to mathematical and scientific computing, and especially important because we'll be starting to use a package called as Numpy. Now, Numpy is a very useful package because it allows you to do a lot of complex mathematical calculations very easily. So we'll get started with Numpy. So first of all, we need to install Numpy in our system. So we'll say pip install Numpy, and using this, we can install Numpy. It has already been installed in my system. So uh, yeah, this has been already installed, but you can install it in your system, and after that we can use it further. So now the first thing that we are going to do is we are going to import Numpy so that we are able to use all the functions that have been written in this package. So we have imported Numpy. Now, one of the major uses of Numpy is using arrays. So arrays can be very easily accessed using NumPy. So we'll do that. So far, the arrays that we know are lists. So we've learned about 1D arrays, 1D lists, 2D arrays, multiple dimensional arrays. So let's start with the arrays that we know. So for example, we start with a list. So we have a list 1, 2, 3. We have another list, say 4, 5, 6, right? And now let's run this code. So we have our list L1 and L2 over here, right? So yeah, now let's say if we have to multiply something to list, say L1. So let's say we have to multiply all elements by 2, for instance. So an easy thing to do would be just L1 times 2, right? And what this does is it creates another list 1, 2, 3 and just mixes the two of them. So basically you have 1, 2, 3, 1, 2, 3. So that's what multiplying a list by 2 does to you. Similarly, if you want to divide it by 2, for example, it won't work. If you have to subtract the two lists, it won't work. If you have to add the two lists, you are going to get the combination of the two lists, L1 and L2. So definitely these different operations are not as simple in a list. And therefore, we start using what are called as NumPy arrays. So the first step to use a NumPy array is to create one. So we'll start by creating a NumPy array. So in order to create a NumPy array, we'll say np dot, because we have imported NumPy as np. So np dot array, and within that we'll write the array. So now since arrays can be written in the form of lists in Python, so we'll include the list over here. So what it would do is it would take this list and convert it into a NumPy array, right? Now we want to store this somewhere. So let's store it in A1. So now if we run this, we see A1 is not stored as a list. Rather, it has been stored as a NumPy array, right? And we can perform all these operations that we just performed on our list. So for example, if I say A1 times 2, so I would just get 2, 4, 6. Each element is multiplied by 2. If I say A1 over 8, so that will divide every element by 8, right? Similarly, we can create another NumPy array, say A2, and that would be the array of this list 4, 5, 6. So if we run this thing, we have two numpy arrays over here, and we can perform addition, we can perform subtraction, and so on and so forth. So we can do a lot of things using our numpy arrays, right? Now these operate you can do similar the same operations using lists as well, using list comprehensions, but that becomes a bit more complicated and inefficient, even for small arrays. But as you go to even larger arrays, as the size of your array increases, these operations become very inefficient and time consuming. Therefore it is usually preferred to use numpy arrays. Okay. So this was creation of a numpy array. One cool thing with numpy arrays that you can do is the use of matrices. So you can deal with matrices in numpy arrays very easily. So whenever you talk about a matrix, matrix is basically a two-dimensional list, right? So whenever we talk about a matrix, you'll need two indices to access that. So for example, if I have to write a matrix, say 1, 2, 3, 4, 5, 6, a matrix of this kind, for example. So in that case, I have my matrix over here, which is a 3 cross 2 matrix, because there are 3 rows and 2 columns. And in order to access any element, let's talk in programming terms. So the first row is going to be the 0th row, 1, 2. First column is going to be 0 and 1. So let's say if this matrix is M, so this is how you can access, for example, this element, right? So this is what a matrix is. So once again, we have to create this matrix for ourselves. So in order to create a matrix, what could we do? We could say M equals to, and remember, first of all, we have to make a list, right? So this matrix contains 3 rows and 2 columns. So we'll make a list, and within that list, we'll add 3 lists. These 3 lists represent 3 rows, right? And after that, we could write 2 elements in each list, because there are 2 columns. So 1, 2, similarly 3, 4, and 5, 6, right? And if you run this, you see the matrix M is stored as a list right now. And if you go to this list, you'll have to access each element over here, right? That becomes difficult. And further on, performing calculations on these elements becomes even more challenging. So in order to access these elements more easily and to do our calculations in better way, we would create a numpy array rather than this list. So we have this list, we'll convert this into a numpy array. So this is what we do, right? So now that would actually create a matrix. And as you see now, it's a lot easier to look at this data. And especially if you have a lot bigger matrix, let's say a 10 cross 10 matrix, then the earlier format, it becomes very difficult, right? And again, performing row operations, column operations becomes a lot simpler in case of a list. So, sorry, in case of a numpy array. So for example, if we have to perform, let's say, this kind of a row operation, say R1 is R1 minus R2, right? Let's say if we want to perform this operation over here, right? So how are we going to do that? So first of all, we have to access the first row. The first row is 1, 2 over here. So how would we access that? So to access that, we will say M, the name of the matrix, the first row, which is 0, comma, and we have to access the entire first row, which means we have to access all the columns. So this colon over here accesses all the columns, right? So M0 comma colon would access all the columns in the 0th row. Similarly, if I say M colon comma 0, this would access all the rows in the first column. So it will give you 1, 3, 5, right? Because we are going through all the rows of the 0th column, right? But let's perform the operation over here. R1 equals to R1 minus R2. So as it is written, we can write the same thing over here in our NumPy array. So we can say M0 comma colon, which is the entire first row, minus M1 comma colon, which is the entire second row, right? And this would perform the matrix operation, right? And when you run this, you will see the matrix M would have changed. The first row has changed, right? You can also multiply 2. Let's say if you want R1 equals to R1 minus 2R2. So this operation is also very simple. You just multiply 2 and you get the matrix M, right? So performing row operations, even column operations, let's say you want the first column to be C1 plus C2, for example. So the first column plus the second column. So that's how you write the first column, all rows of the first column. And that's how you write the second column, all columns of the second, all rows of the second column, right? So this is a column operation over here. So you can very easily perform these row and column operations, right? Now, there are a bunch of things that we can do with NumPy, a lot of mathematical calculations, and we'll learn about these things in the subsequent videos as well. But let's get started by one of the most common applications of matrices, and that is solving a linear algebraic, a system of linear equations, right? So let's start by solving the system of linear equations. So for example, if we have, say, this kind of a system of equations. So we have two equations and two variables, x1 and x2, right? We have two equations, right? And we are going to solve this system of equations, right? So in order to solve the system of equations, we can use matrices. So we can represent the same system in terms of a matrix. So we can make a coefficient matrix like this. We can make a variable vector, and now onwards, whenever we use matrices, double underline implies we are talking about a matrix, and a single underline implies we are talking about a vector, right? So this is a vector over here, and we could have the constant matrix, constant vector C1 and C2. This is this row over here, this column over here. So we finally can write our system of equation in this form, and the solution to this system of equations is just this, right? Now you will have to perform you have to take an inverse of this matrix and so on and so forth. We'll not be doing that in this video, but we'll still be able to solve this system of equations using an inbuilt function in NumPy. All right. But what we'll need for that is our coefficient matrix and the constant matrix over here. Okay. So we'll be formulating the coefficient matrix and the constant matrix, and we'll be solving the system of equations. Okay. So let's do that. So for example, I'll just do a simple example of two equations. So for example, we have the equation 2x plus 3y equals to 5. And the second equation is, say, 3x plus 11y equals to 14, right? So the solution to this is 1 comma 1, by the way. So whenever you substitute x and y as 1 comma 1, you'll get the solution, right? So now let's try to solve this equation. So first of all, we'll make the coefficient matrix. So the coefficient matrix is a list, right? So a matrix basically, so it's a 2D list. It will have 2 rows and 2 columns. So 2 lists within a single list. And in each list, we'll have 2 elements. So the first row is 2 comma 3. So 2 comma 3. And the second row is 3 comma 11. So that's 3 comma 11. And then we'll convert this into a Numpy array. So we've done that. Let's make the constant array, which is 5 comma 14 over here. Right. So we've got our coefficient matrix. We have got our constant vector. And now let's solve. So for solving this, we'll be using a very useful function, which is linear algebra dot solve. And you get this from Numpy. So this is what we'll write: np.linearalgebra.solve. And within solve, we'll put the coefficient matrix first. So that is A, comma, the constant vector B. So this gives you a vector of x and y, right? So let's store that in, say, capital X. And that's it. That is all that you need to solve this system of equations. So when we do that, we see the vector x over here, which is 1 comma 1, right? So this is how you solve a system of linear equations using Numpy. You can do similar interesting things, mathematical calculations using Numpy. So we'll work on all of that together in the subsequent lectures. And hopefully we'll be well versed and we'll be able to use Numpy for our own benefit and for our own chemical engineering problems. So one thing that I would highly recommend is that now that you know how to solve a system of linear equations, try solving some material balance problems that I have uploaded in the chemical process calculations videos before. So you could try these material balance problems, and you basically have to just formulate the equations and then solve them in order to get the answers. So let's hope that we are able to start solving such problems now. All right, thank you.